Well, thank you so much for having me. My name is Tony Shin. I'm a postdoc at Los Alamos National Lab, and I am in the Intelligence and Space Research Division. And today I'm here to talk about Adaptimize, which is our software solution really to better utilize UAVs and unmanned ground vehicles for radiation monitoring and mapping. And so one of the major problems that we're really trying to tackle here is our future decommissioning of many of our nuclear facilities we have. So here in America, we obviously have nuclear power plants as well as research reactors. And these are on average designed to operate for around 40 years. And one of the biggest issues we have right now is actually over half of them, or nearly half of them, are operating beyond this design lifetime. And so that in itself is an issue because the cost of maintaining these facilities is actually greater than the cost of operation and the output we get from these reactors. On a global scale and looking kind of into the future, by 2040, just in America, we're going to have 75 nuclear power plants and 33 research reactors that are going to need to start decommissioning in order to create space for the next generation reactors. And so what we really need right now is a way to not only efficiently, but have accountability behind our dismantling infrastructure. So the standard approach for dismantling is called Deferred dismantling strategy. And so there's three major phases in this operation. First is the immediate removal of fuel elements. And then secondly, we enter this period of deferment. And so during this period, we're solely limited on surveillance and maintenance, maintaining the facility. And finally, when we are done with that period of deferment, we can go ahead and fully dismantle it to its final state. The reason why we have this period of deferment is really to allow these short-lived radionuclides to decay. And this can take up to 100 years, it's typically a few decades. So naturally, this is actually a major driver and cost factor for dismantling strategies. And so we're focusing really our application on this period of deferment. Some of the current challenges we have, so as you can see in this image, the dismantling and the period of deferment requires radioactive material monitoring as well as mapping, contamination. And you see that it's a multifaceted problem where you have contamination maybe inside the building structures, underground piping, ground surface, surface water, etc. And of course, we also have the concerns of offsite contamination. So currently, there are a few ways that this is done. One of them is really in-person surveys, where we send in personnel to do radioactive swipes. There's also static monitoring stations, typically for offsite contamination as well as ground surface monitoring. And lastly, these are far and few between in terms of we have one-time confirmatory surveys to ensure that we are within regulations for our contamination as well as our radioactive material. And all of these, it's really to inform the remediation processes and procedures in order to, again, abide by regulation and also to guarantee safety for the operators. And so the idea of continuous radiation monitoring really engenders the use of UAVs and UGVs. And so if we look at this ecosystem, there's two major parts. Really, one part is the hardware. So there are many companies out there that are designing UAVs, UGVs, as well as radiation sensors. And the point here really is it's come to a mature state where we have efficient, affordable, and commercially available technology at hand to be used. And so for Adaptimize, what we're really focusing on is a software platform that's really concerning itself with the controls of these UAV, UGVs, as well as the data analytics behind the sensor data. And so our solution is to provide a smart mobile sensing software platform to govern the controls as well as the data analytics of the sensor data. So Adaptimize has a few different features that we've implemented in the software platform. One of them is fully autonomous controls, motion controls. Secondly, we have on-the-fly and also continuous mission planning. And I'll explain a little bit how that works on the next slide. We have fast and efficient means for monitoring because we've implemented machine learning predictive algorithms. And lastly, a unique feature for us is we can simultaneously control multiple UAVs and UGVs at the same time. And so again, we're really aiming to have a smarter, faster, and more reliable way of controlling these UAV, UGV sensors. And so Adaptimize is really built on a continuous and autonomous monitoring framework. And the backbone behind Adaptimize is using the concept of using what we know so far. And so we have this framework where we, in real time, take radiation sensitive data from all of our different assets, whether it be in the air or on the ground, and we implement that into our machine learning predictive mapping and monitoring algorithm. And this allows us to have information which can ultimately inform where these assets need to go in order to create a better or more accurate representation of our facilities. Of course, all this information feeds into actionable information that ultimately is aimed for accountability. And so we can have radiation dose maps for safety concerns. We can also have better monitoring and, again, continuous monitoring of radioactive material as well as the environment. And this drains down into our maintenance needs as well as our contamination control of our facility as well as our sites. So when we look at Adaptimize on a performance level, we're really offering the ability to have equal accuracy, but with significantly less cost, training, effort, as well as time. And so Adaptimize, again, because we're optimizing on the fly, it allows us to have maneuver these UAVs and UGVs exactly where they need to be, completely autonomously. And ultimately, we see that this reduces both the operational costs and the financial costs of not only monitoring, but the remediation process itself, because a lot of the remediation procedures is really contingent on how early you catch the contamination and things of that nature. And so we can have a better understanding of our facilities in a shorter amount of time, then we can actually have lower remediation costs. Ultimately, our goal is really to make what is the standard strategy of deferred dismantling an affordable, and not only that, a safe standard strategy for future decommissioning projects. So when we look at the market opportunity just here in America, we have nuclear decommissioning services, which is really governed by the United States Nuclear Regulatory Committee. And so currently we have around 30 nuclear power plants that are undergoing decommissioning. And so we see this market to be around $1.9 billion a year. Of those, 50% are under deferred dismantling and are actually in the period of deferment itself. So we see that to be around $1 billion. And what we're really trying to target here is the continuous monitoring in this period of deferment. So we see that to be around a $200 million a year market. And the main driver for increase in the market is actually, again, due to these more and more of these nuclear power plants need to begin the decommissioning process. So one of the key things we think about, right, is who's really interested in this technology. And so we've identified really the major players of nuclear decommissioning service companies as the potential target customers. And so these companies are responsible mainly due to their knowledge of these facilities themselves, as well as their rapport with the regulatory committee. We foresee these companies using our technology. And of course, we can look at the competitive matrix as well and compare ourselves to similar services and companies that exist. And we can see here that our main benefits really come from the ability to control multiple UAVs and UGVs simultaneously, the on-the-fly mission planning, as well as our machine learning predictive mapping, which really gives us our performance improvements and in turn the benefits. So where were we, where are we at now, and where do we need to go? So last year, we really focused on the development of our predictive mapping algorithm and combining that with our on-the-fly optimization algorithms. And so now we've come up with a fully autonomous control software and navigation policy for our assets. What we're working on currently, so we have indeed verified in simulations that we can get equal accuracy results in less than half the time in some scenarios. And so we are moving forward with a small-scale in-field experiment to validate our results. And of course, simultaneously, once we have that, we're working on an application software to develop a user-friendly software platform and user interfaces so that we can have the end users really use our product. We're also looking into a larger scale demonstration actually in these facilities. And in the future, we're looking for collaboration and licensing procedures as well as distribution to those service companies. So what are we looking for at this point? We're really looking right now, specifically funding to develop, again, our user-friendly application software. We also are looking for collaboration, again, with the government as well as the industry for a few different reasons. One, access to these facilities for our large-scale demonstration, but also to get feedback on what is useful, what isn't useful for the end users who might use Adaptimize. Lastly, we're looking for partners for distribution and hopefully at the end, acquisition of our software. All of this, again, is to ensure the safety, accountability, and reliability for our future decommissioning needs. So with that, I thank you all, and I will take any questions. Thank you so much.
Thanks, Tony. We have a couple of questions from our sharks.
Yeah, sure, Beto. Maybe I'll lead off here. Tony, can you go back to the competitive slide? Competitive matrix, I think you called it. Yeah. So kind of first question is, are you comparing apples and apples here? Is Gamma, Reality, and Measure, and so on, are they in the UAV space from the perspective of delivering that service with that technology?
So I would say Measure and Mirion are actually known for, as well as GRI, they are known for using UAVs specifically for doing their radiation contamination mapping and things of that nature. And for GRI specifically, they're still, they have very sophisticated systems on their UAVs, but it's still single pilot driving their UAVs around. So it's close to apples. However, I think the reason why we have so many other features is that we took a fundamentally different approach of what we wanted to work on. We're not so concerned with the hardware, which all three of these companies do work on hardware. We're much more focused on the software side. So
I think you're getting to the point I was trying to dig into, which is really, have you identified your core differentiation? I'm not sure you did in the slide to me. So then one other quick question, then I'll let Beto jump in. So I've personally seen a whole bunch of companies doing controls for UAVs, for asset management, all kinds of things. Why build a control software for the actual control of the units themselves? That intuitively doesn't make sense to me. Versus building a platform to analyze the data seems to be your differentiation, but I'm not 100% clear about that. So just why build mission control software, and then isn't your core differentiation your ability to analyze this complex data?
Sure. So I guess in regards to that, I think the other differentiator is our machine learning predictive mapping capability. And so the reason why we're using that to create a controls platform is because that really allows us to have dynamic feedback, and that's not something that a lot of people are working with. And so we wanted to remove we'll still have subject matter experts on the ground using this platform, but we really wanted to remove the human factor of driving these UAVs. And so the idea was, can we use that real-time sensor data and implement it through machine learning exactly where we need to go? So I think depending on who sees it, I think maybe the differentiator here is actually our machine learning predictive capabilities.
Well, and you also identified, if you're trying to eliminate the human element here, that's not on your competitive matrix. So just to point out that I think if you worked a little bit harder on the slide, it might really help show how you're different. But let me stop there and let Beto jump in.
Thank you.
Thank you. And I think those are great insights and questions. I want to start, first of all, I really like the presentation. It really touches a lot of elements that are important in understanding a problem and an opportunity. However, this is more on me than you. I still don't understand, because I don't have a background in this industry, why you want to monitor with the level of specificity or continuity a plant that's being decommissioned.
Right.
What is the compelling reason why you want, say, near continuous AUV mapping or kind of a surveying of an area? I surmise it's because you're looking for any possible leakage, any movement in radioactivity, or things of that nature. Can you answer that for me first?
So you hit it right on, that's exactly right. It's really accountability. So I think the major driver here is safety as well as regulations. Safety because, there are people who are entering these facilities and decommissioning other parts that aren't so hot, I guess, in terms of radiation. So safety is a major concern, and regulation really. So for a lot of nuclear power plants, we have these short-lived radionuclides. Cobalt-60 is an example that can be really, really hot. That decay away with a half time of around 5 to 10 or 5.7 years. So it's really an accountability as well as protecting from terrorist threats. So you can also imagine a situation where a terrorist might come in and try to steal this radioactive material to create a dirty bomb. And so these are concerns that are high on low, I would say low probability, but very high risk, catastrophic type.
So then let me offer two thoughts. Clearly an important aspect, clearly a large market, but not an easy one to quote unquote break into, because what I see when I see the competitive slide is some of those companies are over 100 years old. They're very entrenched. In some ways, they would have to take away from a market that they already have and try to deploy it here. So I have two suggestions. The first one is there another analogous industry where you have the same urgency with likely less severity of what that urgency is? So let's look at deforestation or something like that, where you can test the technology and the integration parts, including the integration of hardware and things of that nature. And it doesn't need the decades of monitoring. Maybe it needs a year to year or month to month. And as a way to test out that the platform is working consistent, you can then develop the user interface based on those parameters, which will likely be very, very similar to the other application you have in mind. So that's the first thing. The second would be it sounds like the model, if it works here, could potentially be akin to a software as a service model, which is similar to an annuity on what you've developed. The difficult part of a lot of these things is that they require continuous upkeep of UAVs, et cetera, right? And interpretation of data. Ultimately, all these things that have some element of human error in it, and perhaps on this particular industry, you want less of that.
Right. I see. No, those are great suggestions, and I'll definitely think about how to apply those. I know we did look at other applications. Specifically looking at radiation contamination was really led by the technical effort of this project, but definitely looking to expand and seeing if we can bring value to other applications.